It is the last light of Monday, the 25th of May, 2026. The file is prepared. The instruments have been checked. We begin, as always, with conditions as they stand. And tonight, the face of the sun is quiet. That is the first thing the data tells us. 9 sunspot regions are catalogued on the visible disk as of this filing. Most are small, simple, carrying little magnetic complexity. Solar activity over the past 24 hours has remained at the lowest rung of the scale, the classification the agencies designate as low, with only minor, common-class flares noted. No Earth-directed coronal mass ejections have been detected in available imagery. Solar wind speeds have been slow between 270 and 350 kilometers per second, barely more than a drift relative to what this sun is capable of producing. By every standard metric of the visible hemisphere, the Bureau would characterize tonight's solar face as resting. But the Bureau does not file on the visible hemisphere alone, because what is currently out of sight is not quiet. And we know this because we have, for the first time in history, multiple sets of eyes that can watch the part of the sun we cannot see from here. One of those eyes belongs to NASA's Solar Orbiter, a spacecraft designed specifically for this purpose, circling the sun from a vantage point that gives it coverage of regions Earth-based instruments cannot access. A second set of eyes belongs to a rover on the surface of Mars. NASA's Perseverance, a machine built to search for signs of ancient life in a dry Martian crater, has, in the course of these remarkable few months, turned its cameras toward the sun and captured imagery of active regions the entire day side of Earth cannot observe. A third method is older than spacecraft, helioseismic echo mapping, in which scientists read the interior vibrations of the sun the way a physician reads a heartbeat through a stethoscope pressed to a chest, inferring what is hidden behind a wall of fire by listening to the shocks that travel through it. All three methods are telling us the same thing tonight. There are large, active sunspot regions on the far side of the Sunday, active regions significant enough to have been marked and catalogued. Regions that were described by monitoring services as showing strong active region signatures across the far hemisphere. Regions that are currently hidden behind 865,000 miles of plasma and nuclear fire and that are rotating toward us. The Bureau notes the timing. These hidden regions will begin rotating into view within days. The southeastern limb of the sun, the sunrise edge, as seen from our perspective, is already receiving new arrivals. Monitoring stations reported on the 23rd and 24th of May that incoming regions from the southeast are worth watching. One of those new arrivals fired a flare on the 22nd, before it had fully rotated into clean view. The flare was classified M2-4, a significant event in any quiet period. It also produced a coronal mass ejection, which was captured by the LASCO C2 coronagraph aboard the SOHO spacecraft. By the time the flare was detected, the region that produced it, designated AR4436, had already rotated past the northwest limb and onto the far side, meaning it struck from the edge like a thrown stone from around a corner. That is the solar situation tonight. A quiet face, a noisy far side, hidden fire on its way around the curve. The Perseverance rover and the view from Mars. The Mars Perseverance rover is a machine that was launched from Earth in July of 2020 and landed in Jezero Crater, the floor of an ancient dried lake, on the 18th of February 2021. Its stated mission is to seek signs of ancient microbial life, to collect samples for potential future return to Earth, and to test technologies for future human missions to the Martian surface. It carries cameras, spectrometers, ground-penetrating radar, a miniature helicopter called Ingenuity, and an oxygen production experiment. It was not, in any sense, designed to be a solar observatory. And yet, in the spring and early summer of 2026, the Perseverance rover has been doing something that the scientists who built it must consider extraordinary. It has been imaging active regions on the far hemisphere of the sun that Earth cannot see. The geometry that makes this possible is straightforward when you understand orbital mechanics. Mars and Earth orbit the sun at different distances and different speeds. At certain points in their respective orbits, Mars is positioned such that it can observe parts of the solar hemisphere that are turned away from Earth. The far side of the Sun from Earth's perspective may be the near side from Mars' perspective, depending on the current orbital geometry. On or around the 18th of May, 2026, NOAA issued a formal notice, Near and Far Side Solar Imagery. The notice stated that solar far side imagery from NASA's Solar Orbiter, combined with Perseverance data, meant that the forecast could change significantly for the 20th of May and beyond. The forecast was depending on what was lurking out of Earth's sight. They now had eyes on it. For the entire history of human solar observation, from the Babylonian court astronomers recording sunspots at sunrise to the first systematic telescopic observations of the 17th century, through the establishment of the modern space weather monitoring network in the 20th century, humanity watched the sun only from one direction, from the near side. From what our orbital position allowed us to see, the far side was, in every meaningful sense, unknown until it rotated into view. And even that visibility was limited. A region rotating onto the disk from the limb arrives edge-on, its magnetic structure difficult to read, its true complexity hidden in the foreshortened geometry of the solar limb. Now, a rover on Mars, a rover whose primary purpose is to look for ancient life in a dried riverbed, is watching the sun from a different angle. And a spacecraft in a solar orbit tilted relative to the ecliptic plane is imaging the corona and the far side active regions from a vantage point that no Earth-based instrument can replicate. And helioseismic echo mapping is being updated in near real time. We have, tonight, a more complete picture of the current state of the sun than any generation of humans before this one. And the picture shows hidden fire, large, active, on its way around. There is a second condition the Bureau is required to note, and it has been ongoing for 10 days. On the 16th of May, at 1740 UTC, NOAA's Space Weather Prediction Center issued an alert message code ALTEF-3, serial number 3691. The alert recorded that electron flux in the 2 mega-electron-volt range had exceeded 1,000 particle flux units at geostationary orbit. That is the formal threshold for elevated energetic particle activity, the kind that affects satellite systems, that can degrade solar panels, that poses hazard to astronauts operating outside protective shielding. That alert has been extended continuously through the 23rd of May. By the 22nd, the maximum recorded electron flux reached 3,762 particle flux units. By the 23rd, it had continued climbing. These are not nominal background readings. These are levels that trigger formal government-issued alerts. The cause of a sustained elevated electron flux environment is usually a combination of solar-wind interaction with the magnetosphere over time, particles that have been accelerated and are continuously replenishing the radiation belts. What is notable here is the duration. 10 days of continuous elevated flux is not a single event. It is an environment. The magnetosphere has been processing elevated particle energy for 10 consecutive days. The Bureau does not dramatize this. The Bureau records it. 10 days, continuous, still running. Beyond the far side regions rotating toward us, there is another driver already in transit. Solar monitoring services flagged on the 25th of May that 2 coronal holes designated CH1369 and CH1370 are positioned to send high-speed solar wind streams toward Earth between the 26th and 29th of May. That window begins tomorrow. A coronal hole is a region of the sun's corona where the magnetic field opens outward into space rather than looping back on itself. In these open field regions, solar wind escapes faster than from the surrounding corona, where the standard solar wind reaches Earth at speeds of 300 to 400 kilometers per second. Coronal hole streams can arrive at 600, 700, 800 kilometers per second or beyond. The difference matters because the speed determines how effectively the stream can compress and energize the magnetosphere, and how likely that compression is to drive southward turning magnetic fields, the configuration most effective at coupling with Earth's own magnetic field and opening the door to geomagnetic disturbance. The negative polarity designation noted for the incoming stream from CH1369 is worth marking. A negative polarity coronal hole produces wind carrying a negative magnetic orientation, and southward pointing interplanetary magnetic fields are precisely what the magnetosphere is most vulnerable to. When a negative polarity stream arrives with sufficient speed, the probability of geomagnetic activity increases. Monitoring forecasts for the 26th through 29th of May read, unsettled to active intervals expected. Not a storm warning, but a watch. The Bureau will update as conditions develop. The Bureau wishes to spend a moment on this mechanism because understanding it clarifies why the polarity of the incoming wind matters as much as its speed. The sun's magnetic field extends far into space, forming what is called the heliosphere, the bubble of solar influence that encompasses the entire solar system and extends beyond the orbit of Pluto. Within the heliosphere, the interplanetary magnetic field carries the orientation of whatever part of the sun's surface it originated from. A high-speed stream from a negative polarity coronal hole carries magnetic field lines that point, on average, in the southward direction when they reach Earth. Earth's magnetic field. At the boundary with space, the magnetopause points northward. When the interplanetary magnetic field also points northward, the two fields are aligned and little energy crosses the boundary. The magnetosphere stays relatively closed. When the interplanetary magnetic field points southward opposite to Earth's field, the two fields connect. Magnetic field lines merge across the boundary in a process called magnetic reconnection. Solar wind particles and energy flow into the magnetosphere. Currents form. The ring current, a persistent electrical current that flows around Earth in the inner magnetosphere, intensifies. The conditions for geomagnetic disturbance are in place. The southward component of the interplanetary magnetic field is designated BZ. When BZ is negative, pointing south, reconnection is favored. When BZ is strongly and persistently negative during the arrival of a high-speed coronal hole stream, the result can be a geomagnetic storm lasting hours to days. The solar wind speed determines how much energy is available. The BZ orientation determines how effectively that energy is coupled into the magnetosphere. This is why the Bureau can know, tonight, that a coronal hole stream is coming. We can see the coronal holes, but cannot yet know how significant its geomagnetic impact will be. That information only becomes available approximately 45 minutes before the storm's onset, when the stream passes the L1 monitoring point, the gravitationally balanced point between Earth and the Sun, about 1.5 million kilometers sunward, where NOAA's Deep Space Climate Observatory satellite reads the solar wind in real time. 45 minutes. That is the current warning time for a geomagnetic storm. For the Quebec blackout of 1989, there was no such warning at all. The disturbance overwhelmed the grid before operators had time to shed load or take protective action. Today, those 45 minutes exist. Whether they are sufficient depends on how quickly grid operators can respond and whether protective protocols have been fully implemented across every jurisdiction in every nation. The Bureau does not have that information. But the Bureau notes that 45 minutes is a narrow window. We turn now from the sky to the ground, or rather, to what is beneath it. The United States Geological Survey, Hawaiian Volcano Observatory, filed its daily update at 9:10 in the morning, Hawaii Standard Time on Sunday, the 24th of May. The summary line reads, "The Halema'uma'u eruption of Kilauea is paused." And then, in the same paragraph, forecast models suggest that episode 48 will occur sometime between Monday, May 25, and Tuesday, May 26. Monday, May 25 is today. This eruption, this ongoing, episodic, breathing eruption of Kilauea summit has been running since the 23rd of December 2024. Over the course of 17 months, it has produced 47 distinct lava fountaining episodes, each separated by a recharge period during which the magma reservoir beneath Halema'uma'u crater refills, builds pressure, and waits. Scientists measure this weighting through tiltmeters instruments that detect the subtle inflation of the summit as magma accumulates. When the tiltmeter reading reaches a threshold consistent with previous eruption initiation, the forecast window opens. The window is open now. The eruption that produced episode 47 and that is about to produce episode 48 has been ongoing for 17 months. In that time, Kilauea's summit has been engaged in what volcanologists call an episodic fountain-fed eruption, a pattern in which the magma reservoir fills, erupts in a pulse of lava fountaining that may last hours to days, drains partially, pauses for days to weeks, while the reservoir refills, and then erupts again. The pattern is remarkably regular. The intervals between episodes have ranged from approximately 7 to 14 days. The duration of individual episodes has ranged from a few hours to more than a day. Episode 38, on the 6th of December 2025, produced a reticulite deposit that USGS scientists described in their May 20th update, a layer of lightweight, frothy tephra that has been covered by subsequent episodes but remains visible in ground cracks near the south vent. Reticulite is a particularly light and porous volcanic glass, produced when lava is so gas-rich at the moment of eruption that it froths into a structure more like pumice than solid rock. The presence of reticulite in the tephra deposit is a record of the gas content of the magma at the time, a detail that scientists use to track how the magma chemistry is evolving across the eruption. The tephra cone that has built up around the vents has been measured and tracked. Each episode adds material: lava, ash, reticulite, Pele's hair, Pele's tears. Pele's hair is volcanic glass spun into strands by the motion of gas through erupting lava. It is genuinely hair-like, golden or olive green in color, delicate enough to be carried on the wind for miles. Pele's tears are the small spherical or teardrop-shaped glass beads that form when droplets of lava are flung into the air by the fountain, cool in flight, and land as solid glass. Both are hazardous to eyes and lungs in concentrated quantities. Communities northeast of the park have been dealing with tephra fallout from episode to episode throughout the entire 17-month eruption. The most recent episode, episode 47, ended on May 15th, when lava fountaining ceased at 12:27 in the morning, Hawaii time, after 9 hours of continuous eruption from the north vent. During episode 47, the Uekahuna tilt meter recorded 15.5 microradians of deflationary tilt, the ground subsiding as magma drained from the reservoir and erupted at the surface. Since the end of episode 47, the tilt meter has recorded nearly 11 microradians of inflation. The summit is filling back up. The sulfur dioxide emission rate, 2,000 tons per day, during the current pause is itself a remarkable figure. In ordinary times, Kilauea's background SO2 emission rate is measured in hundreds of tons per day. 2,000 tons per day during a pause between lava fountain episodes reflects the ongoing degassing of a magma body actively present in the shallow plumbing system beneath. Halemaumau, the gas is escaping, even though the lava is not currently erupting. The magma is there. It is releasing its volatiles. The eruption is not over. It is paused. And tonight, the tilt meter says it is nearly time. During episode 47, lava fountains reached 650 feet before slowly declining. Tephra up to 3 inches in diameter fell at the Uekahuna and Keanakakoi overlooks. Fine ash and Pele's hair were carried northeast into communities beyond the park boundary. As of the May 24th update, glow is visible from both eruptive vents overnight. Magma is visible within both vents. Seismic tremor is present and fluctuating. The Bureau offers this figure without further comment: 2,000 tons of sulfur dioxide per day, while paused. The reader may place it against their own sense of what quiet means. The Bureau has noted in multiple recent filings that solar cycle 25 appears to have passed its maximum as of approximately February 2026. The Bureau wishes tonight to be more specific about what a declining solar cycle actually means for the kind of activity the Bureau monitors, because the implications are frequently misunderstood. The solar cycle, the approximately 11-year rhythm of sunspot activity, is driven by the evolution of the sun's internal magnetic field. At the beginning of a new cycle, sunspot activity is low, and the sun's polar regions carry strong magnetic fields of opposite polarity. As the cycle progresses toward maximum, the polar fields weaken and eventually reverse the North Pole's field, becoming south polarity, and vice versa. At maximum, The polar fields are near zero. After maximum, the new polarity polar fields begin to build, and sunspot activity, which has been high, begins to decline. During solar maximum, the most dramatic events, the X-class flares, the major coronal mass ejections, the events most capable of producing G4 and G5 geomagnetic storms are most frequent. But the maximum is also the phase in which grid operators and satellite operators tend to be in their highest state of alert. The declining phase is different. Sunspot activity falls. Major flares become less frequent. The casual observer might conclude that space weather is becoming less dangerous, but the declining phase produces its own hazard, the large coronal holes. As the polar fields reorganize and strengthen in their new polarity, they extend toward lower latitudes, and portions of those polar field structures can detach and become isolated equatorial coronal holes, persistent, recurring, rotating with the sun every 27 days, sending high-speed streams toward Earth on a roughly monthly cadence. The Bureau notes CH-1369 and CH-1370 arriving tomorrow as early representatives of this phase. They will not be the last. The 1989 Quebec event occurred during the declining phase of solar cycle 22, not during its maximum. The event that ended Quebec's grid in 90 seconds came from an active region that was among the last of that cycle's major producers. The coronal hole activity that primed the magnetosphere beforehand was the declining cycle S contribution. This is the scenario the Bureau watches for in the months ahead. Not a single dramatic flare from a single dramatic region, but the convergence of drivers that a declining cycle tends to produce simultaneously. The active regions will become less frequent, but the coronal holes will become more numerous and more persistent, and the magnetosphere may become more sensitive to the southward BZ episodes that coronal hole streams occasionally deliver. That is the briefing as of last light on the 25th of May, 2026. The face of the sun is calm, the far side is not. An elevated particle environment has persisted for 10 days. A coronal hole stream arrives tomorrow, and beneath the crater floor of Kilauea, magma is rising. We now open the file on what came before. The theme that runs through tonight's data is concealment. What cannot be seen from here? What is building on the other side of a wall too large to look past? What is rising beneath a surface too hot to approach? This is not a new condition. Humanity has been surprised by hidden fire for as long as records exist. The Bureau reviews several cases tonight not to predict what is coming, but to understand what kind of thing it is that arrives when the hidden side reveals itself. At 1744 UTC on the 13th of March, 1989, the entire Quebec power grid collapsed. In 90 seconds, 6 million people lost electricity. The blackout lasted 12 hours for most of the province and several more days for remote regions. It is the most consequential geomagnetic storm-induced grid failure in modern history. The storm that caused it, a G5, the highest level on the geomagnetic disturbance scale, had been building for days. It was driven by a large X-class solar flare on the 10th of March, which launched a coronal mass ejection that arrived at Earth 3 days later. But what is less frequently discussed is what preceded and accompanied the flare. A pattern of prior activity, a magnetically complex active region, and a coronal hole stream that had already been sending elevated solar wind toward Earth, creating a magnetosphere that was primed and compressed before the main ejection arrived. The Quebec event was not a single blow from a single cause. It was a convergence, a region that had been building complexity during its approach. Background conditions already elevated, a magnetosphere under pressure for days before the critical moment. At the moment the storm struck, the induced ground currents overwhelmed the protective equipment at Hydro-Quebec's substations. Equipment designed and tested to handle the worst conditions engineers in 1989 believed they needed to plan for. What arrived was larger than the worst case. The grid went down not because anyone failed to do their job, but because the engineers had been working with an incomplete picture of what the sun was capable of. The Bureau notes that 6 months before the March event, a monitoring satellite had detected an active region of comparable magnetic complexity rotating onto the disk from the solar limb. That region had not produced a major event. Scientists noted its complexity and tracked it. It rotated away without a major eruption. 6 months later, a similar region rotated in, and the result was Quebec. The hidden side, again, the arriving region, the quiet before. In 1989, the tools available to watch the far side of the sun were none. Every forecast was based on what the near hemisphere showed. Scientists knew, in a theoretical sense, that active regions invisible to Earth could be rotating toward them. They had no way to see them until they crested the limb. Today, we can see. Not perfectly, but the solar orbiter, the helioseismic echo maps, and the Mars Perseverance rover have given humanity something that did not exist in 1989. The ability to know, in advance, that something is coming. We know, tonight, that large active regions are on the far side and rotating toward us. The Quebec engineers did not have that knowledge. We do. The Quebec blackout produced, in its aftermath, a significant shift in how the space weather community and the power industry related to each other. Prior to March 1989, space weather was largely the domain of scientists and communications engineers. The power industry, the operators of the high-voltage transmission grids, had not been substantially engaged with solar activity as an operational concern. The 90-second collapse of Hydro-Quebec changed that. In the years following Quebec, NOAA's Space Weather Prediction Center expanded its operations and its relationship with the power industry. The North American Electric Reliability Corporation, the body that sets reliability standards for the bulk power system in the United States and Canada, developed geomagnetic disturbance standards. Utilities began installing devices designed to block or limit the flow of geomagnetically induced currents through transformer windings. Research into the vulnerability of high-voltage transformers to GIC increased substantially. Some utilities developed playbooks for shedding load or taking other protective action when geomagnetic storm warnings were issued. The Bureau notes, without passing judgment, that the implementation of these protective measures has been uneven. Some utilities are well prepared, others have made less progress. The standards that exist are minimum standards, and in the space weather community there is ongoing discussion about whether those minimums are sufficient to prevent a Quebec-scale event from producing Quebec-scale outcomes today. The honest answer is, for a Quebec-scale event, probably yes, probably manageable. For a Carrington-scale event, much less certain. 37 years have passed since Quebec. The Bureau watches the southeast limb of the sun tonight, where new active regions are rotating toward visibility, and files this historical note as context. The lesson of Quebec was learned at significant economic and safety cost. The question of whether it was learned thoroughly enough to handle what might come next remains, in the Bureau's assessment, open. Between the Carrington event of 1859, which the Bureau covered in the previous package, and the Quebec blackout of 1989, there is a significant case that receives less attention than it deserves. The New York Railroad storm of May 1921. On the 13th and 14th of May 1921, a geomagnetic storm of extraordinary intensity struck Earth. The storm's origin was a series of large solar flares from an active region near the solar disk center, the worst possible geometry for Earth, since disk center flares direct their coronal mass ejections most directly toward us. The geomagnetic disturbance that followed reached intensities that, by modern standards, would be classified somewhere in the G4 to G5 range, among the most severe on record for the modern era. In New York, the induced ground currents overwhelmed the signal and switching systems of the Central New England Railroad. The railroad's central tower in Brewster, New York, caught fire. The induced electrical current ignited it. Across the broader New York area, telegraph and telephone equipment failed. Switchboards burned. In Sweden, the storm caused a major fire at the Telegraph Central Station in Uppsala. In Australia, equipment failures were reported across the communications network. The 1921 event is sometimes called the second largest geomagnetic storm of the modern era after 1859. It is the largest such event for which we have detailed infrastructure impact records across multiple continents simultaneously, and its peak intensity, measured through the global network of magnetometers that existed in 1921, appears to have been comparable to portions of the Carrington event, making it, if the Carrington event had not already established a benchmark, an event that would be considered without precedent. The 1921 storm struck a world that already had extensive electrical infrastructure, telegraph networks, early telephone systems, electrified railways, but had not yet built the high-voltage, long-distance power transmission networks that came with mid-20th century rural electrification. The vulnerabilities of 1921 were real and the impacts were significant, but the grid architecture of 1921 was, by accident, somewhat more resilient to geomagnetically induced currents than modern infrastructure. The lower voltages and the more distributed topology meant that cascading transformer failure was less likely to develop. The Bureau notes that we are now 105 years beyond the 1921 storm. The world has changed. The grid has changed. The satellite constellation upon which our navigation, communications, and financial systems depend did not exist in 1921. The question of what a 1921 class event would do today remains one of the more uncomfortable open questions in infrastructure resilience planning. The far side active regions rotating toward us tonight are not predicted to be the source of such an event. The Bureau makes no such prediction. The Bureau simply notes that the 1921 storm also began with a region rotating into view from the solar limb, firing its first notable flares as it crested the edge, and then delivering its main event from near disk center 3 days later. Regions arrive, then they fire from the center. The sequence is consistent. The autumn of 2003 produced one of the most intense periods of solar activity in the modern instrumental record. Between the 19th of October and the 4th of November, the sun produced 17 major flares, including 2 of the most powerful X-class events ever recorded. The second of those, on the 4th of November, saturated the instruments designed to measure it. The official classification was X17-4. Analysis of the distorted instrument response suggested the actual intensity was closer to X28, which, if confirmed, would make it the most powerful solar flare ever directly measured. The storms that followed disrupted satellites. They forced the International Space Station crew to take shelter behind the most radiation-shielded section of the station. They produced auroral displays visible at latitudes as far south as Texas, Florida, and the Mediterranean coast of Europe. They caused a major blackout in southern Sweden. They permanently damaged at least 2 spacecraft. They disrupted aviation routing across the polar regions. What is notable about the Halloween storms for tonight's purposes is how they began. The primary active region responsible for the largest events had been monitored as it rotated across the disk. Scientists watched it build. They tracked its growing magnetic complexity. The daily space weather forecasts in late October 2003 carried escalating probability estimates for major flares, and yet the scale of what arrived exceeded every model. The X17 to X28 flare on November 4th struck with a magnitude that surprised even those who had been watching the most carefully. This is the lesson the Halloween storms carry. Watching is not the same as being prepared for the full range of what a watch thing can do. The active region was visible. It was tracked. It had been classified as complex, and it still exceeded the upper bound of expectation. Tonight, the Bureau is watching active regions on the far side that have not yet shown us what they are capable of. AR 4436 fired an M2-4 flare from behind the limb before we could fully see it. We do not yet know the magnetic classification of the regions currently hidden by the far side. We do not know their complexity. We do not know whether, when they rotate into view in the days ahead, they will carry the kind of magnetic delta class configurations that produce X-class events. We are in the position of knowing something is coming. We do not yet know its name. On the 23rd of July 2012, the Sun produced a coronal mass ejection of extraordinary power. The ejection was launched from a complex active region and traveled through space at a velocity estimated at over 3,000 kilometers per second, roughly 3 times the speed of a typical fast CME. By the time it passed through the point in space occupied by the Stereo-A spacecraft, it had the characteristics of what scientists later modeled as a Carrington-class event. It missed Earth by 9 days. The orbital geometry on the 23rd of July 2012 placed Earth approximately 9 days ahead of where the ejection was aimed. The CME traveled outward through the solar system along a trajectory that intercepted Stereo-A but not Earth. Had it struck, scientists who later modeled the event estimated it would have caused geomagnetic disturbances potentially exceeding those of the 1859 Carrington event. A 2013 study estimated economic damage from a Carrington-scale event at between $1 and $2 trillion in the United States alone. A 2008 National Academy of Sciences report projected that a severe geomagnetic storm could leave 130 million Americans without power for months to years due to damage to high-voltage transformers that take years to manufacture and have no large stockpile of replacements. 9 days. That is the margin by which humanity avoided testing those estimates in 2012. The July 2012 event also illustrates something relevant tonight. The active region that produced the ejection had been on the far side of the Sun just days before. It rotated into view, was identified as magnetically complex, and within days produced the most powerful CME of the modern era. The trajectory by fortune was wrong for Earth. The Bureau makes no predictions about what the incoming far-side regions will produce. The Bureau records what is known. There are complex active regions currently rotating toward us. The history of such arrivals is not uniformly uneventful. On the 8th of June, 1783, a fissure opened in the Laki volcanic system in Iceland. It was not a single event. It was the beginning of 8 months of eruption, during which approximately 14 cubic kilometers of lava poured across the landscape of southern Iceland, and an estimated 120 million tons of sulfur dioxide was released into the atmosphere. The Laki eruption did not produce a dramatic volcanic explosion visible from a distance. It was a slow exhalation, a horizontal bleeding of magma from a long fissure in the ground, spreading across the plains, releasing gases into the atmosphere at a rate that continued day after day, month after month, without the theatrical violence of a Plinian column or a pyroclastic flow. It killed approximately 20% of Iceland's population, not through lava, but through the fluorine released with the gases, which contaminated pastures and water sources and caused the livestock deaths that led to a famine. And it changed the climate of the northern hemisphere. The sulfur dioxide released by Laki formed sulfate aerosols in the stratosphere. These aerosols reflected sunlight. The summer of 1,783 inches Europe and North America was characterized by a persistent dry fog, a bluish haze in the sky that contemporaries wrote about with confusion because it appeared in calm weather and would not disperse. Benjamin Franklin, then serving as the American minister to France, was among the first to suggest in writing that the haze and the unusual cold that followed might be connected to volcanic eruptions. He was correct, though it would be generations before the mechanism was fully understood. The winter of 1783 to 1784 was one of the coldest on record across the northern hemisphere. The Mississippi River froze at New Orleans. Ice formed in the Gulf of Mexico. The harvest failures that followed in France contributed to the conditions of economic distress that led, 6 years later, to the French Revolution. The Laki fissure system remained active from the 8th of June 1783 through the 7th of February 1784, 8 months in which the eruption ebbed and surged, but never fully ceased. The total lava volume covered approximately 580 square kilometers of Icelandic highland, an area roughly the size of metropolitan Los Angeles. The eruption produced more sulfur dioxide in those 8 months than all of Europe's combined industrial activity in any single year of the 20th century. The blue haze, as it came to be called across Europe, was observed from Iceland to North Africa. Ships at sea in the North Atlantic described visibility so reduced that navigation was impaired without any obvious atmospheric cause. No storm, no fog, no rain. The sun appeared through the haze as a dim red disk, insufficient to warm the ground below it the way a summer sun should. Crops failed not because frost killed them, but because the light was wrong. Photosynthesis requires a certain quality of sunlight, a certain intensity across the spectrum, and the Laki haze filtered out enough of that spectrum to stunt growth across an entire growing season across an entire hemisphere. The Bureau files this detail tonight because sulfur dioxide is the common chemical between the Laki eruption and the present condition at Kilauea. 2,000 tons per day. Paused, not erupting, simply breathing. The comparison is not equivalence. Laki's output was orders of magnitude greater and sustained over months. But the Bureau finds it instructive to track the same molecule across 2 centuries and 2 very different eruptions, because it reminds us what this particular gas is capable of at scale and what it means that any eruption produces it at all. Kilauea is not Laki. Episode 48 will not change the Northern Hemisphere's climate. But the Bureau finds it instructive to hold the Laki record alongside the current Kilauea data, because it reminds us that volcanic systems speak to us in multiple registers. The lava fountaining is the visible speech. The sulfur dioxide, 2,000 tons per day, even during a pause, is a quieter language, accumulating in ways that a daily update does not fully capture. If Laki represents the slow hidden fire, the exhalation across months, then Tambora represents the sudden catastrophic release. On the 10th of April 1815, Mount Tambora, on the island of Sumbawa, in what is now Indonesia, produced the largest volcanic eruption in recorded history. The explosion was heard over 3,000 kilometers away. The eruption column reached into the stratosphere. Approximately 100 cubic kilometers of material was ejected. The following year, 1816, became known in New England as 1800 and froze to death, and across Europe and North America as the year without a summer. Snow fell in New England in June. Frost killed crops in July and August. Famine spread across Europe. The harvest failures triggered waves of migration. The mood of a generation was shaped by the persistent cold and uncertainty. In Geneva, in the summer of 1816, a group of writers sheltering from the unusual weather held a contest to write ghost stories. One of the stories produced in that wet, cold summer was the story of a scientist who built life from dead matter and could not control what he had made. Mary Shelley was 18 years old. The book became Frankenstein. The Bureau does not suggest that Tambora caused Frankenstein, but the Bureau notes that the hidden fire of an Indonesian volcano cast a shadow across the cultural imagination of an entire generation in ways that the people of that generation could not have anticipated when the mountain erupted in a place most of them had never heard of. This is what large volcanic events do. They reach further than their smoke. There's one more piece of the historical record the Bureau wishes to note tonight, because it shapes the context within which all of the above events are being tracked. Solar cycle 25 appears, based on accumulated monitoring data, to have exited the solar maximum phase as of February 2026. The smooth sunspot number reached its peak in October and November of 2024. The northern polar field of the sun has weakened considerably in the months since. Solar cycle 26, which will follow the coming minimum, is already being assessed, and early indicators, including the state of the polar magnetic fields, have led some forecasters to suggest that cycle 26 may be significantly weaker than cycle 25. This is worth holding in context. The most dangerous phase for infrastructure from space weather is often not the solar maximum itself, but the declining phase, the years immediately following the peak. This is because the declining phase tends to produce large coronal holes as the polar magnetic fields reorganize. Large coronal holes produce persistent high-speed streams, exactly the type of driver that contributed to the Quebec event in 1989, which occurred during the declining phase of solar cycle 22. The southern polar coronal hole has already formed and appears to be growing. CH13 provide and CH1370 arriving tomorrow are early examples of what the Bureau expects to be an increasing pattern of coronal hole activity as cycle 25 continues to decline. The Bureau will track this. The historical record teaches the same lesson in multiple languages. Hidden fire arrives. The visible face can be calm, while the far side builds. The quiet before an episode is part of the eruption, and the declining phase of a solar cycle carries its own distinctive hazards. We now open the oldest part of the file. The Bureau does not believe that ancient peoples possessed instruments capable of detecting helioseismic echoes. They could not see the far side of the Sunday. They did not know what a coronal hole was. But the Bureau has observed, across many filings, that ancient traditions independently and across vast distances developed frameworks for understanding the observable universe that encoded certain recurring truths. Tonight's theme, the hidden fire, the quiet face that conceals what is building, the cycle of eruption and recharge, runs through the oldest records with striking consistency. The Bureau presents those records here, not as prophecy, but as testimony. These are accounts from people who watch the sky and the earth more consistently and with greater attention than most modern individuals ever will. In the cosmological tradition of ancient Egypt, the sun personified as Ra did not simply set in the evening and rise in the morning. The setting of the sun was understood as the beginning of a journey. Ra entered the underworld, called the Duat, at sunset. He traveled through 12 hours of darkness, passing through a series of gates, each guarded by entities whose names had to be spoken correctly to secure passage. At each hour, the regions of the Duat would briefly light with his presence and then return to darkness as he passed. During the night journey, Ra was hidden from the world of the living. The world above the horizon received no light, but Ra was not absent, he was traveling. He was moving through the hidden realm, renewing himself, preparing for the emergence at dawn. The Egyptians described this process using the word keper, becoming. Ra in the Duat was in the process of becoming the sunrise, Ra regenerating, transforming, building toward the return. The Bureau finds several elements of this account striking when held against tonight's data. The far side of the sun, the hemisphere invisible from Earth, is, in a precise astronomical sense, the part of the sun that is turned away from us, traveling in the sun's rotation from its period of hiding toward its period of visibility. The large active regions currently on the far side are, like Ra in the Duat, in the process of becoming. They are building, they are rotating, they are preparing for emergence. The Egyptian ritual texts of the Amduat, the book of what is in the underworld, describe in careful detail the 12 hours of Ra's journey. Each hour has a name, a set of inhabitants, a characteristic danger, and a characteristic reward for proper navigation. The fifth hour contains the Sokar region, a place of dense, impenetrable darkness even within the darkness of the Duat, where Ra's passage is described as moving through sand and rock rather than open space. It is the deepest point of the hidden journey, the farthest from the visible world. And it is where, according to the text, Ra's rejuvenation is most fully accomplished. The hidden darkness is not punishment, but preparation. The 12th hour brings the emergence. The final gate opens. The solar bark passes through the body of a great serpent, the Mihen serpent, and comes out the other side as the scarab, Khepri, the god of the rising sun. The hidden fire becomes visible. For 30 centuries, Egyptian kings and priests recited the Amduat in temples oriented precisely toward the cardinal directions. They watched the sunrise as an affirmation of something they believed they understood, that the fire which appears every morning was never absent, only hidden, and that hidden things are not the same as absent things. The Bureau files this alongside the helioseismic echo data without further comment. The ancient Mesopotamian solar deity Shamash in the Akkadian tradition, Utu in the earlier Sumerian, was understood as the god of justice as well as the god of the Sunday. This is not an arbitrary association. The connection between solar observation and justice emerges from a practical reality of ancient administrative life. The sun's behavior was the most reliable public clock, available to a pre-technological civilization. Shamash, daily crossing of the sky, was a visible standard against which all other measurements of time could be checked. But Shamash Shamash' role extended beyond timekeeping. Shamash was the one who saw everything, who traveled across the sky and illuminated every corner of the world, making visible what was hidden, exposing what was concealed, revealing the truth that darkness and deception tried to maintain. In the legal tradition of Mesopotamia, Shamash was the divine witness to every oath, the guarantor of every judgment. Swearing by Shamash was swearing by the one who could not be deceived, the one who saw from the highest vantage point what was happening on the surface below. The image on the famous stele of Hammurabi, the black basalt pillar on which the Babylonian law code was inscribed in the 18th century BCE, shows Shamash seated on his celestial throne, handing the symbols of law to Hammurabi. The sun rays emanating from Shamash's shoulders in the image are not decoration, they are his nature, the illumination that makes justice possible. The Bureau finds this tradition resonant with tonight's theme in a specific way. Shamash sees from above what we cannot see from below. The solar orbiter, circling the sun from a vantage outside the ecliptic plane, sees what Earth cannot see. The Mars Perseverance rover sees the solar hemisphere turned away from Earth. The helioseismic echo maps read the interior of the sun as though listening through walls. We have built, in the 21st century, something that functions remarkably like the all-seeing eye that the Babylonians attributed to Shamash, an extended monitoring network that observes the sun from multiple directions simultaneously. The difference is that Shamash, in the Mesopotamian tradition, chose what to reveal and what to conceal. The data coming from our instruments gives us no such discretion, it simply reports what is there. The hidden active regions on the far side are not concealed by divine intention. They are concealed by geometry. And geometry, unlike divine will, can be worked around. This is what the space age has accomplished. In one of its less celebrated dimensions, we have given humanity something closer to the all-sky view that ancient traditions imagined only their gods possessed. Among the oldest textual compositions in any surviving Indo-European tradition, the Rigveda contains hymns to Agni, the god of fire, that circle around a single fundamental paradox. Fire is everywhere, hidden in the world, and everywhere capable of emerging. The most direct expression of this is found in hymn after hymn, addressing the fire as one who is concealed within wood. The kindling fire, the friction fire, produced by the drill and the board, was understood not as fire being created, but as fire being found. Agni was inside the wood. The ritual act of firemaking was an act of calling the hidden one out of hiding. In the Rigveda, third mandala, Agni is addressed as the one who hides in the secret places, who lurks within the dark, who must be summoned through the correct invocations and the correct actions. The priests who maintained the Vedic fire traditions, who kept the sacred hearth burning for generations across the migration of peoples from the steppes of Central Asia into the Indian subcontinent, understood fire as something that existed prior to human knowledge of it. The fire was not invented, it was discovered, it was encountered, and before it was encountered, it had been there all along, hidden. The early Vedic texts also describe a cosmic fire that the gods themselves had hidden beneath the waters. There are passages in which Agni is said to have fled from the demands placed on him, to have submerged himself, to have hidden in the depths of rivers and seas, to have made himself invisible. The gods and the seers had to find him again and call him back to the surface. The Bureau finds this image resonant with the geology of tonight's second condition, the magma beneath Kilauea's Halemaumau crater. Magma is, in the most literal sense, fire hidden beneath a surface. During the pause between episodes, the fire retreats. The tilt meter records its return. The vents glow because the fire is present, even when it has not yet erupted. And then, as has happened 47 times since December 2024, the correct conditions accumulate and the hidden one emerges. Tonight, the fire is building again beneath Halemaumau. The tilt meter is near threshold. Agni, in the old language, is stirring. The Hawaiian tradition of Pele, the volcano deity associated with lava, fire, and creation is one of the most detailed indigenous frameworks for understanding episodic volcanic activity ever documented. And it is directly relevant to the geology of Kilauea because the tradition developed among a people who lived with Kilauea is eruptions across centuries who watched the episodic behavior of this volcano, not as a geological curiosity, but as the central organizing reality of their landscape. In the Hawaiian tradition, Pele is not simply a deity of destruction. She is a deity of transformation of the ongoing process by which new land is made from old fire. The lava flows that destroy forests and villages are understood in the same tradition as the act of creation, the building of new earth at the ocean's edge, the extension of the island into the sea, the perpetual act of generation that has, over millions of years, produced the island chain itself. The episodic character of Pele's eruptions, the pauses, the build-ups, the fountaining episodes, the retreats, is embedded in the traditional accounts. The legend of Pele's journey across the Hawaiian island chain, moving from the oldest islands in the northwest to the youngest and most active in the southeast, encodes the geological reality of the hotspot track. The magma source is moving beneath the Pacific plate, and Kilauea represents the current position of Pele's dwelling. She is not permanent in any one place. She arrives, she works, she pauses, she moves. The concept of Pele's rest, the pause between eruptions, was not understood in the tradition as the absence of Pele, but as Pele's presence in a different mode. She was there. She was working beneath the surface. The land above her was warm. The gases rose. And when the conditions were correct, she returned to the surface. Traditional practitioners who maintained knowledge of the land around Kilauea's summit were often able to read signs of approaching eruption that Western scientific observers in the 19th and early 20th centuries could not. This knowledge, embedded in generations of observation and encoded in ceremony and in the place names given to features of the volcanic landscape, represents one of the longest continuous records of Kilauea's behavior available to any people. Tonight, episode 48 is forecast to begin within hours. Pele, in the old language, is at home. In the Maori tradition of Aotearoa, New Zealand, the origin of fire is given as a theft. The hero Maui, the trickster demigod whose exploits include fishing up the North Island from the sea and snaring the sun to slow its movement across the sky, goes to the underworld to steal fire from Mahuika, the guardian of fire, who is described in some accounts as an old woman and in others as a being whose fingers and toes are the flames themselves. Maui convinces Mahuika to give him fire, one flame at a time. She gives him a fingernail flame. She pulls off a burning fingernail and gives it to him. Maui extinguishes it in a stream, returns, asks for another. Again and again, until Mahuika has given away most of her fire. When she realizes she has been deceived, she releases what remains, throwing her last flames into the world. The flames spread, trees catch fire, the world burns. In the crisis, the rains come. Tawiri Matea, the god of wind and storms, produces rain that fights the fire, but the fire does not die completely. At the moment of greatest intensity, Mahuika, at the instruction of the ancestor, Tane hides the remaining fire inside certain trees. The kaikomako, the maho, the pate. These are the trees from which fire can be drawn by friction. The fire is hidden inside the wood. The Maori people learn to find it there. The Maori story of Mahuika is, like the Vedic account of Agni in the wood, a story about fire that survives by hiding. The catastrophic release, the throwing of remaining flames into the world, is followed by concealment. The fire that burns everything becomes the fire hidden inside trees, recoverable only through skill and knowledge and the correct technique. The Bureau reads this alongside the electron flux data. The ALTEF-3 alert has been running for 10 days. The electron flux at geostationary orbit has reached nearly 4,000 particle flux units. This is elevated energy, the charged particles of the solar environment pressing against the magnetosphere. And in the days ahead, coronal hole streams are incoming, and active regions are rotating toward the near side. The fire is not hidden, but its behavior, how much it will release, to what magnitude is still concealed within the geometry of the far side. In the Norse cosmological tradition, the world was created from the interaction of two primordial realms, Niflheim, in the north, a region of ice and mist and cold, and Muspelheim, in the south, a realm of fire. Muspelheim existed before the gods. It was not created by the gods, and it cannot be destroyed by them. It simply is an eternal reservoir of heat at the edge of the cosmos. The Prose Edda, compiled by Snorri Sturluson in 13th century Iceland, describes Muspelheim as existing at the farthest southern boundary of the Norse cosmos. It is guarded by a being named Surtur the Black, who sits at its edge with a flaming sword, waiting. Surtur does not act during the age of the gods. He sits, he waits. His fire stays at the boundary. At Ragnarök, the end of the age of gods, Surtur rides out from Muspelheim. The fire he carries engulfs the world. The gods fall, the 9 worlds burn. And then in the version preserved in the Voluspa, the oldest of the Eddic poems, the world rises again from the sea, green and renewed. A new generation of gods emerges from where Valhall stood. Life returns. Scholars of comparative mythology have long noted that this structure, the eternal hidden fire at the edge of the cosmos, the waiting guardian, the eventual release, the renewal appears in some form across multiple northern traditions. The ancient Icelanders who compiled and preserved this tradition lived with volcanic fire as a constant companion. Muspelheim's geography, in certain readings, looks remarkably like the volcanic landscape of Iceland itself, where fire emerges from fissures in the ground with little warning, where ice and fire coexist at the surface. The people who told the story of Surtur waiting at the edge were the same people who survived on the flanks of active volcanic systems. They knew that the fire at the edge was real, they knew that it waited, and they encoded that knowledge in a story about the end and renewal of the world so that those who came after them would not forget what had been learned. Among the pre-Columbian traditions of the Andean region, the Inca civilization developed one of the most sophisticated solar observation practices in the ancient Americas. The Inca ruler, the Sapa Inca, was understood to be the son of the sun, Inti. The solar deity Inti was not merely worshipped. The entire political and agricultural calendar of the Inca Empire was organized around the movement of the sun across the sky and the precise observation of solstices and equinox. At Cusco, the capital of the Inca Empire, the Coricancha, the Temple of the Sun, was the most sacred site in the empire. Its walls were lined with gold, and at the center of its worship was a large golden disc representing Inti, oriented to catch and reflect the first light of the rising sun on solstice and equinox mornings, flooding the temple interior with light at precisely the moments the astronomical calendar required. The priests who maintained the Coricancha were among the most educated individuals in the empire, responsible not only for religious observance, but for the agricultural timing decisions that determined when to plant and when to harvest across the length of an empire that stretched from modern Colombia to central Chile. But the Inca relationship with the sun was not only about the visible and the regular. The Inca tradition included a sophisticated understanding of solar variability of years, when the sun's behavior seemed different, when harvests failed, when the rains came at the wrong time. The high-altitude agricultural systems of the Andean Plateau were vulnerable to even small shifts in climate, and the Inca agricultural administration had developed an extensive network of grain stores, the colca, specifically to buffer against the years when the sun did not cooperate. Some researchers have noted that the colca system, the massive state storehouses distributed across the empire, represents a kind of infrastructure specifically designed for the aftermath of the hidden fire. Not volcanic or solar fire specifically, but the systemic disruption that follows any large natural event. The stores existed because experience had taught that there would be years when the visible order of things, the regular sun, the expected rains, the reliable harvests would fail. And when it failed, the stored abundance of previous good years would be the difference between survival and catastrophe. The Bureau considers this a sophisticated form of preparedness. The Inca did not know that a volcanic eruption in Indonesia might change their climate. But they knew, from the accumulated experience of generations living in a seismically and volcanically active landscape, that the system of the natural world was not perfectly reliable, and they built their civilization's resilience around that knowledge. Tonight, as Kilauea prepares for episode 48 and coronal hole streams approach from a solar cycle now declining from its maximum, the Bureau finds the Inca model worth holding in mind. Not the religious framework specifically, but the institutional memory it encoded. That the sun's fire, however regular it appears, carries within it the capacity to surprise, and that the appropriate response to that knowledge is not fear, but preparation. Across the diverse traditions of indigenous North America, the relationship between celestial fire and terrestrial life takes many forms, too many and too varied, to survey comprehensively in a single Bureau filing. But the Bureau wishes to note several traditions that speak specifically to the theme of hidden fire and its return. Among the Lakota people of the Great Plains, the Sungwi is one of the primary spiritual forces recognized in the tradition. The Lakota sun dance Wiwang Wachipi, the dance while gazing at the sun, is one of the most significant ceremonies in the tradition, performed annually, requiring months of preparation and days of continuous ceremony. The dance is not merely a solar celebration. It is a renewal ceremony, an act of sacrifice and commitment through which the dancers participate in the renewal of the world. The sun, in the Lakota tradition, is not a passive presence to be celebrated. It is a living force that requires acknowledgement, reciprocity, and the correct relationships to continue its life-giving function. The Anishinaabe tradition of the Great Lakes region holds a significant body of sky knowledge in the Midewiwin, the Grand Medicine Society records, transmitted across generations in the form of birch bark scrolls and oral teachings. Some of these teachings encode detailed knowledge of celestial phenomena, including records of events that researchers in the modern period have identified as probable aurora and meteor observations going back centuries. The Anishinaabe word for aurora wawate, sometimes translated as dancing lights, appears in oral tradition in ways that suggest both regular observation and the recognition of the aurora as something that increases and decreases in activity over time. The Pueblo peoples of the American Southwest, including the Hopi, Zuni, and Acoma, developed astronomical observation traditions of remarkable precision, aligned in their architecture with the movements of the sun, moon, and particular star groups. The Hopi cosmological tradition includes the concept of Kachinas, spiritual beings, who return from the San Francisco Peaks region to the villages for half of each year, bringing rain and renewal, and who return to their home beyond the mountains for the other half. The Kachina cycle encodes an understanding of the sun's annual pattern as a rhythm of presence and retreat, not as a permanent constant. The Bureau notes that these traditions, like all the ancient traditions reviewed in tonight's file, could not have known what space weather is in the modern scientific sense. But they observed, consistently, that the sky communicates that its unusual behaviors correlate with something significant in the world below. The aurora was not background noise to peoples who observed it carefully. It was a message. The nature of the message differed by tradition, but the recognition that the message was being sent was universal. Tonight, as the coronal hole streams from CH1369 and CH1370 approach, aurora activity may increase at high latitudes. People who live far enough north to see the northern lights, the Wawate, may see them more brightly and at lower latitudes than usual in the days ahead. The ancient observers who watched the same lights would have known something unusual was happening. The Bureau now knows, in somewhat different terms, why. The Aboriginal Australian peoples maintain the longest continuous cultural tradition on Earth. Archaeological evidence places their continuous occupation of the Australian continent at a minimum of 65,000 years, and the oral traditions encoded in the dreaming accounts represent a record of observation and understanding that has no parallel in depth elsewhere in human experience. Among the astronomical traditions preserved across Aboriginal Australian groups, several are directly relevant to tonight's conditions. The Yolngu people of Arnhem Land in the Northern Territory track celestial cycles with a precision that researchers have documented only in recent decades. Their knowledge of star patterns, of the movement of the Milky Way, and of the relationship between sky conditions and seasonal change on the ground represents a practical astronomical tradition developed over tens of thousands of years of observation. The Yolngu and related groups have traditions that encode knowledge of unusual atmospheric phenomena, what in the Western record would be identified as geomagnetically induced aurora events. Oral histories collected in the 20th century from elders who held knowledge of the tradition describe sky fire events, great lights in the sky that appeared without lightning, that spread across the night in colors that were not associated with ordinary atmospheric phenomena. These events were understood not as random but as significant as indications that conditions in the broader cosmos were in a particular state. The dreaming accounts do not, of course, describe coronal mass ejections. They describe the experience of the events such ejections produced: the lights, the atmosphere, the sense of a world in heightened activity. But the attention paid to these events, the fact that they were recorded in the oral tradition and passed down as significant information, reflects an understanding that the sky communicates and that its unusual communications deserve special notice. There is also, within several Aboriginal traditions, a sophisticated understanding of fire as a land management tool, the practice of cultural burning, which has been the subject of increasing scientific attention in recent decades as climate-driven fire conditions have made fire management a critical, practical concern across Australia. Cultural burning is, among other things, a practice of managing the hidden fire, the dry matter accumulated in the understory, the fuel load that, if left unattended, leads to catastrophic, uncontrolled fire. The Bureau finds a resonance in this that deserves noting. The coronal hole streams approaching Earth, the active regions rotating toward the visible hemisphere, the accumulated electron flux energy in the radiation belts, these are, in a functional sense, fuel loads. Not fuel that can be burned away by a controlled fire, but energy states that can interact with Earth systems in ways that range from auroral spectacle to infrastructure disruption. The question of whether those interactions remain in the range of spectacle or become something more significant depends on conditions whose details we do not yet fully know. Management of hidden fire requires knowing it is there. The 65,000-year tradition of the oldest continuous culture on Earth understood this. The Bureau, in its own much younger way, knows it is there. The Bureau will watch. The astronomical records maintained by the Imperial Court of China constitute, along with the Babylonian tablets, one of the two oldest systematic observational archives available to modern researchers. The Chinese astronomical tradition was practiced continuously, under state sponsorship, from roughly the 12th century BCE onward, and the surviving records, compiled into official histories at the end of each dynasty, contain detailed descriptions of celestial events spanning more than 3,000 years. Within these records are detailed observations of sunspot activity far earlier than the European tradition usually credits. The earliest Chinese record confidently identified as a sunspot observation dates to approximately the 2nd century BCE during the Han Dynasty. The records describe dark spots visible on the solar disk at sunrise or sunset moments when the sun's disk can be viewed without eye damage through the reddening effect atmosphere at the horizon. Some of these descriptions are sufficiently precise that modern researchers have been able to correlate them with the solar cycle record, providing data points that extend our knowledge of solar behavior back 2 millennia. The Chinese tradition also recorded aurora events under the designation of what translates roughly as red or colored vapors or red emanations. Analysis of these records by modern researchers has identified dozens of events described with sufficient detail to be identified as probable major geomagnetic storm events. The geographic range of aurora visible from China, roughly the latitude range of 30 to 40 degrees north, means that only the most significant geomagnetic storms would have been visible, making each such record a marker of an exceptional event. The court astronomers maintained continuous records because their civilization understood that the sky was relevant to governance. The mandate of heaven, the philosophical principle underlying Chinese imperial legitimacy, held that a ruler's continued authority was in part demonstrated by the stability and predictability of the celestial order. Anomalous sky events, eclipses, comets, unusual stars, colored sky phenomena required formal notice and, in some cases, formal response. The emperor was expected to fast, to issue decrees of concern, to signal that the court was paying attention to what the sky was communicating. This was, in effect, an institutionalized form of the Bureau's own function. Systematic attention to what the sky is doing, formal record-keeping, and communication to those in positions of responsibility. The ancient Chinese court astronomers would have understood immediately what the Bureau is doing tonight. They did the same thing, in whatever form their tools and their tradition made available to them every night for 3,000 years. And they could not see the far side of the sun either. Every 52 years, the Aztec civilization performed a ceremony called the Toxiumolpilia, the binding of the years, which, in the accounts given to Spanish chroniclers and preserved in the codices that survived the conquest, is described with terms that indicate the scale of the concern it addressed. At the end of each 52-year cycle, the Aztec people waded through what they believed was a period of extreme danger. They put out all fires in the city of Tenochtitlan. They broke their household gods and threw them into the water. They fasted. They waited on the hilltop called Huizactlan, watching the night sky. What they were watching for was whether the Pleiades star cluster would pass the zenith at midnight, an event whose occurrence was understood as confirmation that the universe would continue for another 52-year cycle. If the Pleiades failed to cross the zenith, the sun would not rise again. The world would end in darkness. When the Pleiades crossed the zenith, as they did, every 52 years, because they always do, a new fire was kindled on the chest of a sacrificial victim on the hilltop, and runners carried firebrands from that new fire down to the city, relighting the hearths of every household in the correct order. The terror was resolved. The fire came back. The Bureau reads this ceremony as an institutionalized response to a real and recurring anxiety that the fire might not return, that the sun, which had always risen, might one day not. The anxiety was cosmological, but the experience that generated it was real. The Aztec and their predecessors had lived through solar eclipses, through years of unusual weather driven by volcanic eruptions they could not explain, through comets and unusual sky phenomena that seemed to announce the possibility of catastrophic disruption. The new fire ceremony is, among other things, the cultural response of a people who lived in a landscape of active volcanoes, who had seen fire vanish and return, who had seen the sky do things they could not predict. The terror they addressed every 52 years was the terror of the hidden fire staying hidden. The relief they celebrated was its return. Tonight, Kilauea's episode 48 is approaching. The magma that has been hidden beneath Halemaumau is preparing to emerge. And when the lava fountains rise as they will, as they have 47 times before, someone in Hawaii will see the fire return. The ancient record, across every civilization the Bureau has reviewed tonight, knows the same truth, that fire hides and that it returns. That the quiet face is not the final word. That the far side, the underworld, the duat, the muspelsheim, the magma beneath the calm floor of the crater, these are not absences, but presences in a different mode. The hidden fire is never gone. It is becoming. We proceed to the final section. The Bureau has reviewed the data. The Bureau has reviewed the history. The Bureau has reviewed what those who came before us knew and recorded in their own languages about hidden fire and its return. We close with what the Bureau sees, stated plainly. As of this filing, the visible face of the sun is quiet. 9 sunspot regions. Low activity. No Earth-directed coronal mass ejections. The far side is not quiet. Large active regions detected through helioseismic echo mapping, solar orbiter imagery, and data returned by the Mars Perseverance rover are currently rotating toward the near side. One of those regions, AR 4436, already demonstrated its capacity by firing an M2 4 flare from behind the limb before it had rotated into clean view. The Bureau does not know the full magnetic classification of the other incoming regions. The Bureau does not know whether they will produce significant events when they rotate into view. The Bureau knows they are there. The Bureau will watch the southeast limb in the days ahead. The ALTEF-3 alert elevated 2 mega-electron-volt electron flux has been in effect since May 16. The flux reached nearly 4,000 particle flux units by May 23. This is an environment, not an event. It means that the radiation belts have been energized and have remained energized across 10 consecutive days. The Bureau notes that satellites operating in geostationary and medium Earth orbits have been operating within this elevated radiation environment for the entire period. Cumulative radiation exposure is a real concern in prolonged elevated flux environments. Coronal holes CH1369 and CH1370 have been identified as the sources of high-speed solar wind streams currently in transit toward Earth. Arrival is expected between May 26 and May 29. The character of the incoming stream, negative polarity, which means southward-oriented interplanetary magnetic fields, increases the probability of geomagnetic coupling when it arrives. Unsettled to active geomagnetic conditions are possible. A geomagnetic storm is not currently forecast as likely, but cannot be ruled out if the stream's magnetic field orientation cooperates with the coupling conditions. Residents at higher magnetic latitudes above approximately 50 degrees should be alert to the possibility of aurora displays through the end of May. Lower latitudes are unlikely to see significant auroral activity unless the storm reaches G2 or higher on the geomagnetic scale. The USGS Hawaiian Volcano Observatory has placed the forecast window for Kilauea's eruption episode 48 between today, May 25, and tomorrow, May 26. The tilt meter is near threshold. Magma is visible in both vents. Sulfur dioxide emissions are running at approximately 2,000 tons per day. Seismic tremor is present and fluctuating. The Bureau will watch the USGS updates through the night. When episode 48 begins, the Bureau will note it. Episode 48 will be part of an eruption that has now been running episodically for 17 months since the 23rd of December, 2024. Each episode has added material to the floor of Halemaumau crater, built the tephra cone at the vents, sent volcanic hair and ash downwind into communities that have been living with this eruption for more than a year and a half. The eruption is not destroying homes, not advancing toward populated areas. It is a summit eruption contained within the caldera, but it is a significant ongoing geological event, and the Bureau treats it as such. Pele is at home. Solar cycle 25 appears to have passed its maximum. We are now in the declining phase of the cycle, the period during which the polar fields reorganize, coronal holes become increasingly prominent, and high-speed solar wind streams become a more frequent feature of the space weather environment. The historical record of declining phases, most notably cycle 22, whose decline included Quebec 1989, suggests that this period carries its own distinctive hazards. The Bureau is not predicting a Quebec event. The Bureau is noting that the conditions which produce Quebec-class events, persistent coronal holes, elevated solar wind speeds, southward turning interplanetary magnetic fields are the conditions that become more common, not less, in the declining phase. We are entering that phase now. The Bureau closes the formal note with a forward-looking summary of what the next 7 days are likely to bring based on current data. May 26 to 29, coronal hole stream arrival, CH1369 and CH1370 are expected to deliver high-speed solar wind during this window. The Bureau will monitor KP index, BZ orientation at the L1 monitoring point, and geomagnetic activity levels. If BZ turns and remains significantly southward during the stream's arrival, a geomagnetic storm is possible. The Bureau will note any formal storm watches or warnings issued by NOAA SWPC. May 25 to 26, Kilauea, episode 48. The window is open as of this filing. The Bureau will update when the eruption begins. Key monitoring parameters: the Ue Kahuna tiltmeter, seismic tremor amplitude, and visual observations from the Halemaumau webcams operated by the USGS Hawaiian Volcano Observatory. Late May into early June, far side regions rotating into view. The large active regions currently detected on the solar far side will begin rotating onto the visible disk within approximately 5 to 10 days, depending on their current longitude. As they crest the southeast limb, the Bureau will assess their magnetic classification, their complexity, and their potential for flare activity. A region that fires M or X-class flares as it rotates onto the disk will be a primary watch item for the next package. The ALTF-3 alert has been continuous for 10 days. The Bureau will watch for either resolution, a return to background levels below the 1000 PFU threshold, or escalation. If incoming solar wind drivers from the coronal hole streams energize the outer radiation belt further, electron flux could increase. The Bureau will report any change in the alert status. The Bureau is tracking, across each filing, the state of the sun's polar fields as they reorganize in preparation for the next solar cycle minimum and the eventual onset of cycle 26. The polar field reversal has been completed for cycle 25. What follows now is the slow strengthening of the new polarity polar fields. The speed and strength of that buildup is the best available early indicator of what cycle 26 will look like. The Bureau will note any significant developments in this progression. The Bureau closes, as always, with an accounting of uncertainty. The Bureau does not know the magnetic classification of the large far side active regions rotating toward the near side. We know they are there. We cannot yet read their character. The Bureau does not know whether the incoming coronal hole streams will produce the southward BZ orientation required for strong geomagnetic coupling. This can only be determined when the stream arrives at the L1 monitoring point, approximately 45 to 60 minutes before it reaches Earth magnetosphere. The Bureau does not know whether episode 48 of Kilauea's eruption will be similar to episode 47 9 hours, 650-foot fountains, or larger or smaller. The tiltmeter data constrains the timing but not the magnitude. The Bureau does not know what cycle 26 will bring. The early indicators suggest a weaker cycle. A weaker cycle means fewer major solar events, but a weaker cycle also means more prominent coronal holes during its declining phase. The space weather of the next 11 years will be shaped by a sun we have not yet fully read. These uncertainties are not failures of the Bureau. They are the nature of the condition. The hidden fire hides. We watch the edge. We record what comes around it. We note what came before. We file the report at last light, and we return tomorrow. The Bureau does not end tonight's filing with a prediction. The Bureau ends with an observation. Everything the Bureau has reviewed tonight, the helioseismic echo data, the solar orbiter imagery, the Mars Perseverance solar observations, the tiltmeter curves from Halemaumau, the electron flux alerts from NOAA, the coronal hole stream forecasts, the solar cycle progression, all of it describes a system that is alive, that is changing, and that carries more information in its behavior than any single night's report can fully contain. The historical record adds depth to that observation. The 1,989 Quebec operators who watched their entire grid collapse in 90 seconds were not negligent or unprepared by the standards of their time. They simply did not have the data that would have let them see what was coming. The Halloween storms of 2003 surprised every satellite operator and grid manager who had been watching the active regions develop for weeks. The near miss of 2012 was a near miss by geometry, not by foresight. The 1,921 New York Railroad storm burned a switching tower in Brewster, and nobody at the time could have told you why a quiet night produced a fire in an electrical system. The ancient traditions, Egyptian, Vedic, Hawaiian, Maori, Norse, Babylonian, Incan, Anishinaabe, Chinese, Aztec all arrived at the same fundamental orientation through independent paths. That the fire exists beyond what we can currently see, that it follows cycles, that its hidden phases are not its absent phases, and that paying attention, careful, consistent, systematic, humble attention is the appropriate response to living in the presence of something that vast. The Bureau is, in its own way, practicing the oldest human discipline there is. We watch, we record, we look at the edge of what is visible and try to understand what is coming around the curve. Tonight, large active regions are coming around the curve. The magma beneath Halemaumau is rising. The coronal hole streams are in transit. The electron belts have been elevated for 10 days. The solar cycle has begun its decline. None of this is cause for alarm in the ordinary sense. All of it is worth knowing. The Bureau knows it. The Bureau files it. The Bureau will be here tomorrow, at last light, to report what the curve reveals. There is something worth saying, at the close of this filing, about the practice of watching itself. The Bureau does not produce these reports because it believes that watching prevents what comes. A coronal mass ejection aimed at Earth will arrive regardless of whether the Bureau has filed a report about it. Kilauea episode 48 will begin whether or not the tilt meter data has been narrated to anyone. The hidden fire on the far side of the sun does not pause its rotation because someone on Earth is paying attention. The Bureau watches and reports because what humanity does with the warning, if there is warning, depends entirely on whether the warning was received. The 45-minute L1 window that gives grid operators a chance to respond to a geomagnetic storm exists only because someone built the monitoring satellite, and someone is watching its data stream, and someone has been trained to interpret the southward turning of BZ as a signal that requires action. The chain from observation to action is long and fragile at every link. The Bureau is one link in that chain. The ancient traditions the Bureau reviews in these filings were, in their own contexts, the same kind of link. The Babylonian court astronomer who noted an unusual red sky and filed it in the day tablet was doing something structurally identical to what the Bureau does tonight, converting observation into record, giving the community a memory of unusual conditions that might inform future response. The Chinese court astronomer who noted an aurora over the northern horizon was extending the institutional memory of the dynasty by one more data point. The Hawaiian practitioner who read the signs of approaching eruption in the volcanic landscape was providing the community with a lead time that could mean the difference between survival and catastrophe. The form changes, the instruments change, the vocabulary changes, the practice, systematic, humble, consistent attention to the behavior of a living planet and a living star does not change. It is as old as human intelligence, and it is, the Bureau believes, one of the most fundamental things that intelligence can do with itself. Tonight, the Bureau has watched. Tomorrow night, the Bureau will watch again.